since we want to relate pairs of components in a chemical reaction, we can figure out that those components could be two reactants, two products, or one reactant and one product. For example, in these combustion of octane, we can figure out the relationship between octane and oxygen being 2 moles of octane react or need to react with 20 moles of oxygen in order to have a stoichiometric reaction, a reaction in which both components are expected to fully react, having no leftovers at the end of the reaction. If that is true, we can also observe that the relationship between the number of moles of octane to the number of moles of CO2, 16, is going to give this stoichiometric relationship, the stoichiometric factor, 16 moles of CO2 being produced by the reaction of the stoichiometric reaction of 2 moles of carbon octane. That means that the octane is completely transformed into the products. Okay, stoichiometric reaction, the right amounts in which the two components reacting are fully consumed, no leftovers behind. The kind of calculations, and obviously from this one you can yourself inquire about any other kind of relationships that we can establish. So I leave that for you to practice. Another important thing that we can have here to recognize the type of calculations that we may find is that since we're talking about a chemical reaction and we're using the stoichiometric ratios, the idea is that we have molar ratios that are coming from the stoichiometric coefficients. So that means that we will always have to calculate the two different amounts in terms of moles of A with respect to moles of B. And that relation, those are going to be related through the stoichiometric factor, mole of A to mole to B, mole of B to mole of A, depending on the situation. But in some cases, it's true that we may start with, for example, the mass of one of the compounds, the mass of A, and we want to find out what is the mass of B that can be produced. When we have these kind of problems, you have to remember that you always have to go through the number of moles of A and B and use the conversion factor, the stoichiometric factor, in order to make that conversion. And again, we need these moles, we need to go through the moles because we're using molar ratios from the stoichiometric coefficients in a chemical reaction. We can have, for example, mass to mass, mole to mass, mass to mass, mass to moles. Okay. One particular example, let's say that we want to find, using stoichiometry, the number of moles of a compound that will produce the number of moles of a different compound. For this particular problem, we need to know the number of moles of water that can be produced for a given amount of moles of octane. So since we're already giving moles and we want to calculate number of moles, we don't need to make any additional conversion. But we still have to find out what is the stoichiometric relationship between these two components, octane and water. So we look at the two components, octane and the stoichiometric coefficients, and water, and we're going to find that the relationship is going to be 18 to 2, and that's going to become our stoichiometric factor. This is the one that we're going to input here in order to make the conversion between the number of moles of octane and the moles to the moles of water that are being produced. Another example could be, now if we go from mass of one compound to the mass of a different compound. Again, now since we started with mass and we need to calculate mass, we don't have the number of moles, but again, since we're using the stoichiometry of the reaction, we need to find the number of moles of the given compound to find the number of moles of a particular product. And from that, we can actually calculate masses. So in order to calculate mass, in order to calculate the number of moles from the mass, remember that we need the molecular mass or the molar mass of that one compound. And to go from the number of moles of the second one to the mass, to its mass in grams, we need to find out, we need to use its molar mass. Now, moles and moles, we always have to go through the moles, and we have to use the stoichiometric relationship between these two components. In this case, we look at oxygen and CO2. We find that those stoichiometric coefficients are 25 and 16, and using dimension analysis, we can figure out that the stoichiometric factor ends up being 16 moles of CO2 to 25 moles of oxygen. So for this particular example, we start with a given mass of oxygen, and we want to find out how many grams of CO2 can be produced. So these two kind of examples where you can extrapolate and you can come up with your own idea of different combinations of this type of problems, but all of them will be solved in a similar fashion.